What you see here is it says draw a line representing the rise and a line representing the run of the line. And then it says state the slope of the line in simplest form. So what we're going to do is practice something that we would have done in Math 1, Algebra 1. And it says click twice to plot each segment. So we're doing rise and run. So rise is how the graph moves up and down. So what you look for is a grid line that the graph intersects. Right here, you can pick this one or any along the way, but I'm going to pick this one because I see it right away. So I click it, and then I'm going to go down until I see on the graph another place where the graph intersects at a coordinate. See right there, it's going to intersect. So I need to go down that far so that it's going to hit that coordinate when I make a nice little right triangle. So the whole idea of slope is that you're making a right triangle. So I click that dot, and then I'm going to click it again because now I'm going to apply a horizontal line to see that it makes a right triangle, so that I can count rise and run. The idea with slope is that you're ultimately counting a right triangle so that it gives you the height vertically and then the run horizontally. So now we count down below. It says the slope of the line. So we actually need to count the rise divided by the run. So I'm rising 1, 2, 3, but I'm going down. So it's a rise down. And then a run of 1, 2, 3, 4, 5 boxes. So I'm just literally counting boxes there. And so the slope of this line, I go ahead and enter it as -3/5. You submit that, you should get a green check mark, and you're good to go on slope. All right. So now the last problem was going down from left to right. This problem is going up from left to right. So immediately I want to recognize the last problem was different. It had negative slope. This one's going to have positive slope. So I find any grid line along the way, click a dot, and then I'm going to need to find another dot along the way. I can go this way, or I could have gone down. It's easier to go to the right when you're counting. So I'm going to eventually get to that dot right there. So I don't want to make this line. I want to make a vertical line that goes up so that I can make a right turn and go over to that dot. So I click here, click again, drag it over here, and now I have made a right triangle. And then you want to count it. And you can look at the grid lines and count that way, or count boxes. I always count in the middle of the box so that I don't screw up and overcount or undercount. So this is 1, 2, 3, 4 is the rise, and the run is 1, 2, 3, 4, 5. So rise 4, run 5 is what I'm going to enter into this box down here. So 4 divided by 5 and submit. So anytime we're asked to find the slope between 2 points, there's 2 ways to do it. You could do a stack and subtract method, but I like to default back to the slope formula. M equals slope. M is slope, and the formula is y2 minus y1 over x2 minus x1. So it's a very basic formula that we would have hit in Math 1 or Algebra 1. And so what I do is I just need to recognize that this x2, x1 business is just saying, like, this is your point 1 and this is your point 2. This is an x value. This is a y value. This is an x value. This is a y value. So all we're doing is saying, well, this is the first x and the first y. This is the second x and the second y. And it actually doesn't matter which order the coordinates are named. Point 1 or point 2 could be flipped. But once you decide it's point 1 or point 2, you've got to stick with it and then put them in the right place. So here you replace the y2 with the -13. So you put -13 minus, and we replace the y1, and notice I did go ahead and put the minus sign, with -7. So I put -7 here. Now I'm going to go ahead and put parentheses around the -7 because it's a minus a negative, because I'm going to take care of that in a second. And then we've got x2 is 8 and x1. So I'm going to I put that down there. So it's 8 minus x1, which is the 7. And then once you set it up, it's a matter of carrying out the arithmetic properly with the minus and negative especially. So I'm going to go ahead and change that to plus plus. Minus and negative turns into plus a positive. So it's -13 plus 7 divided by 8 minus 7. I'm going to go ahead and take care of that, make that a 1. And so now you take care of negative 13 plus 7 should get you a negative 6 over 1. And negative 6 over 1 is just 6. So you put 6 as your answer. Yeah, negative 6. So make sure we get the whole right answer. Now, again, remember, this is your rise. This top part is your rise. The bottom part is your run. So now we have another example. These are just going to vary in the result. So we got the same equation, y2 minus y1 over x2 minus x1. So you label them. This is an xy. It's my first one, so it's 1, 1. And this is a xy. It's my second one, so it's 2, 2. So then I just replace them in the corresponding spots. Y2 is negative 8 minus y1 is also negative 8. Divided by x2 is negative 9 minus x1 is negative 10. Now, why I picked this example next is because on the top, when I do the arithmetic with the negative negative, that turns into negative 8 plus 8, which is 0. The bottom doesn't really matter as long as it's a number, which it is. It's a positive 1. But the slope result is 0. You do actually want to say the slope is 0. What people do is they say 0 and they get weird and say no slope or undefined and they get weird, but you got to be specific. It is 0 slope, and what that means is you have a horizontal line somewhere graphically through those two dots at a y height of negative 8 specifically. Anyway, slope is actually 0. So again, carrying out slope on this one, this is a case where both the x's are the same. So when you subtract, so we'll call this x1, y1, x2, y2, this will be 10 minus negative 2 over 4 minus 4. Now, as long as the top is a number, in which this will be, not 0 is what I mean, but when you subtract the bottom, you get 0. The top is 12. Plus here. What happens anytime you get an over 0 result, we know that we can't divide by 0, and so we want to say that that is undefined. Now, that is a result. It's important to say undefined as a slope result. It means, so you would click this button right here, but what it means is you have a vertical line. All vertical lines have undefined slope. So I have one more practice here. This one is not that unique of a result like the other ones, but here we go again. X1, Y1, X2, Y2 is Y2 minus Y1 is negative 14 minus negative 2. Put that in parentheses because you got to deal with that minus negative. And then negative 15 minus negative 7. Put that in the parentheses because you got to deal with negatives on the top and the bottom of the fraction. So here in the numerator, we change that to plus plus. So 14 plus 2, negative 14 plus 2 is going to be negative 12. And then on the bottom, plus plus, negative 15 plus 7 will get us negative 8. Now, because we have a negative over a negative, did I get negative 8? I meant, yeah. Now, dividing here, we have a negative divided by a negative, and that turns into a positive. We also want to reduce here because we have 12 over 8. So it's positive 12 over 8, but we don't want to put that in as our result because the numerator and the denominator have like factors. So 4 goes in the top and bottom. If I divide the 12 by 4 and the 8 by 4, the result will actually give me 3 over 2 is my slope that I would put down here. Often we're given equations of lines in standard form, and then we have to put them in slope-intercept form, mostly because it's very convenient to graph out of slope-intercept form. Standard form is the way this one is given. It's it's actually typically ax plus by equals c. This one, they switch places with the x and the y. That doesn't really matter. But slope-intercept form is where we're headed. which is why it doesn't really matter. We want y equals mx plus b form, where the slope is present here. That's why we call it slope. And then the intercept, the y-intercept, is the b value. So that's what we want this to turn into. So to do that, what we do is isolate for y. Anytime you're being told to put it in slope-intercept form, ultimately this means isolate y. And so what we want to do is look at this equation and look at what's with the y on the same side of the equation with the y, and we've got a 3x and a 2. What I encourage students to do is to look at what's not attached with multiplication to the y and move that first. This is not attached, so it's easiest to move, and we use inverse operations to move it. So I'm going to add the 3x to both sides to move it to the right. And what'll be left on the left-hand side is just 2x, because these 3x's will cancel. So I get 2y is equal to, and then I want to order and organize this to look like my slope-intercept form. So I want the x to go first, and it doesn't matter which way it goes because you can add in any direction because of the associative property. So we can say 3x plus 6, and then the only thing I have to do is divide by the 2. The 2 is being multiplied, so its inverse operation is divide. So I divide everything by 2. And you can either put an all over 2, or it's just convenient to go ahead and divide each term by 2, because that's really what you're going to end up doing anyway. So then that reduces to be y equals, and then I would go ahead and write that as a fraction. You can write 3x over 2, but you want to see it as 3 halves because that's the slope. So 3 halves x plus 3. All right, again, our goal and our objective is to basically get it to slope-intercept form. And again, this says it's in standard form. That was the directions, but they're out of order. That's okay. But slope-intercept form, prompt is really solve for y. Isolate or solve for y is the goal. So isolate or solve for y. So here we go. Move the unattached thing. I'm going to add 3x to both sides of the equation. And then the 9y is left by itself. 9y equals, and I'm going to put the x first. You could put 18 plus 3x, but it's not in slope-intercept form because I get a y equals mx. So this is 3x plus 18. And then to finish, I just divide everything by the 9. The inverse operation is 9 multiplied. So I divide, and I divide each thing by 9, the 3 by the 9, and the 18 by the 9. And what that'll give me is y by itself equals this fraction here at 3/9. You could write that, but we're going to end up needing to reduce it. So I'm going to write it for a second. 3/9 x, and then plus 18 over 9. And then I'm going to reduce that. So it's going to turn into 3/9 is really 1/3 x, and then 18/9 is really 2. So you want to reduce it, get it all the way to reduced form so that you can see that the slope is actually 1/3, not 3/9. I mean, 3/9 is the same thing, but you want to count up 1 over 3, and then the y-intercept would be 2. When we need to find an average rate of change, let's first define average rate of change to be, average rate of change is slope. It's the secant slope. If you were thinking about it from a calculus perspective, that's what we identify it as. A secant slope is just regular slope. It's y2 minus y1 over x2 minus x1. Our foundational skill of Math 1, Algebra 1, regular slope is a calculus deal. Like, we have to go all the way to calculus and hang on to this. As long as we identify the average rate of change to be that slope formula, it guides our process. The process is we need 2 coordinates. We need a x1, y1, and an x2, y2. Well, when they give us our interval here, they're telling us this is your x1, this is your x2, because in order, there's a first x and a second x. All we have to do is figure out what's the y1 and what's the y2 that go with these x's. And so the way that you do that is you plug in your x values into whatever function you were provided. So essentially our y1 is going to be g of -9. Our y2 is going to be g of 1. Once we find out what those values are, then we just use the secant slope formula, the regular slope form, y2 minus y1 over x2 minus x1. So let's find g of -9. You can use a calculator to do it, whichever way you want to work that. But g of -9 means you plug in -9 for x in these two locations, wherever their x's would be in your function. In this function, we have two places. So this is going to be -9 in parentheses squared plus 10 in parentheses times -9 plus 23. So then we just go ahead and throw that in our calculator. All right, so after throwing in our calculator, we get 14, positive 14. So now we do the same exact thing with 1 and plug the 1 in wherever there's x's. So these same two arrow locations. So it should be going right here and then again right there. So we do 1 squared. The parentheses don't really matter. So this is positive 1 plus 10 times 1 plus 23. And then you can throw that in your calculator if you like, but this one's a little bit easier to just do. It's 1 plus 10 plus 23, which should get you 34. So now what we did is the foundation work to figure out my two coordinates. Essentially, what I just discovered is that my job is to do the slope between -9, 14 as my first coordinate, as my point 1, and 1, 34 as my point 2. So anytime you're asked to find an average rate of change over an interval, the job just got harder than it was earlier, where we just said, hey, find the slope between 2 points. Now there's a whole direction that we have to go to find the 2 points. And then once I have the 2 points, now I do the slope formula. So now I come over here and plug in to my y2 a 34. And now I plug into my y1 a 14. And then I replace the x squared, x2 with 1. And then I plug in, finally, my x1 with -9. I'm going to put the parentheses around the -9 because I got to change that to be a plus plus. And then you work it out. 34 minus 14 is going to give us 20. And then 1 plus a 9 is going to give me 10. So very conveniently, after all that long, hard work, we just have to take 20 divided by 10 and get 2. So my final answer, the average rate of change over the interval, was 2. And that's what I plug in the box